we have already seen that if we use approximate quantities in a calculation, then the number of significant figures changes. For example, you want to calculate the density of a material whose measured mass has, say, 3 significant figures, but the measured volume has 2 significant figures. So when you divide the mass value by the volume, the result numerically may have many digits. However, according to the rule for division and how many significant figures the final answer should have, it is 2. So that means you have to remove some digits, and that's where rounding of uncertain digits comes. So your final answer should have only one uncertain digit, which is the last one, and the ones before that are certain digits. But how do you do that? Say the result of some calculation is this, 2.746. However, here there are 4 figures, 2, 7, 4 and 6, but actually the result should have only 3 significant figures. That means this 6, this last one is insignificant. Now, if you just simply remove 6, will you just simply write 2.74? No. However, if you apply that same procedure to this number, 1.743, and say here also you want only 3 significant figures, that means you have to delete this 3. Here, however, you do not do anything to the number. So what are the rules when we do this kind of deletion? Actually, you already know the rules. The preceding digit means the digit that you are removing, the one before that. The preceding digit has to be raised by 1 if the insignificant figure to be dropped. For example, here the insignificant figure is 6. That's why it has been underlined that it's going to be dropped, it's going to be removed. Is more than 5. If this insignificant figure to be dropped is greater than 5, then we add 1 to the preceding digit, and that's why it becomes 2.75, that 4 becomes 5. Whereas, if the insignificant figure to be dropped is less than 5, then we do not change the preceding digit. For example, 1.743 becomes just 1.74 because the digit 3 to be dropped is less than 5. However, if the digit to be dropped is equal to 5, then what are the rules? Let's see. Here the rules are these. So here the insignificant figure, that is the one to be dropped, is exactly equal to 5. Now if the preceding digit is even, then we do not do anything to it. When we drop 5, that is 2.745 becomes 2.74. However, if the preceding digit is odd and the insignificant digit is 5, then we add 1 to the preceding digit. So 2.735 becomes 2.74. And there is one more thing which of course we understand is that we may not always have to remove just one digit. We may have to remove many digits. There may be many digits in your final answer, but you only want some first few. So the other insignificant digits that come before this one where we want to do the cut, they do not matter. Okay, so you do not have to look at them. They don't affect these rules. This is another thing that has to be kept in mind when working with approximate quantities, that you should not do that rounding off in the intermediate step of a calculation. Say you are doing a complex calculation which has many steps and you are using these approximate quantities. You use them fully and you should retain, you should keep at least one digit more than the significant digits in your calculation, and only when you reach the end of the calculation should you do the rounding off. So in the language that is given in the book, in a complex multi-step calculation where there are many steps, we should retain one more digit than the significant figures in the intermediate steps. In the middle of the calculation, we should not do rounding off and should round off to proper significant figures at the end of the calculation only. At the last step only we do the rounding off. Also, values of some known quantities which are known within many significant figures may be rounded off when used in a calculation. For example, this is the speed of light in vacuum, some such number times 10 to the power 8 meter per second. So, when used in a calculation, in its place you can do the rounding off here and can instead use the value 3 times 10 to the power 8 meter per second. So, whatever you do to this part, this remains untouched. Okay, 10 to the power 8 stays 10 to the power 8. And then there is this thing also. If we have exact numbers in some kind of formula, then these exact numbers have infinitely many significant digits. A number would be considered exact in this context of approximate quantities if it comes from mathematics, not from some physical experiment. 2 pi is exact because its definition is mathematical. The speed of light in vacuum is not exact because it has to be measured by conducting some physical experiment. That's the difference. But anyway, the point here is that if you have an exact number, then it has infinitely many significant digits. So, in some specific calculation, you can choose as many as you need in that calculation from that available infinitely many digits, which is the case with 2 pi. Next, we have this example. Say there is a cube whose side lengths have been measured and this value was found 7.203 meter. So, in this measured value there are 4 significant figures. 7, 2 and 0 are certain and 3 is uncertain. We do not have to discuss about certain and uncertain figures, but I am just simply reminding you. Now, what are the total surface area and volume of the cube to appropriate significant figures? So, to calculate the surface area and the volume, we have to apply the formulas, the known formulas. That means we have to use this approximate quantity in a calculation. So, the final result of the calculation won't really have exactly this many significant figures. So, that means we have to round off the final answer. So, there we have to use these rules. But before that, to appropriate significant figures means what should the final answer be? I mean, how many significant figures should it have? For that, you go back to the rule for multiplication and division involving approximate quantities. So, there the final result should have that many significant figures as we have in that quantity with the least number of significant figures. Because here only one such approximate quantity is involved and there are 4 significant figures. So, the final answer should also have 4 significant figures. So, let us see the solution. So, in the solution we write the in the beginning itself we write the final answer should have answers, both of them should have 4 significant figures. And the reason you have to actually write all the things, why this is the case. So, whatever I said just now, we write those things. And then we calculate the surface area. The formula for the surface area is 6 times side square. A cube has 6 sides and each side is a square. So, each side will have surface area side square. So, 6 times that many squares. And mathematically this figure comes where you can see that there are many digits. However, you want only 4 significant figures. So, besides these 3, before the decimal point you want only 1 more. So, that means your insignificant figures, all these are insignificant figures, 9, 9, 2, 5, 4. You have to remove all of them. So, these other insignificant figures do not really matter. this one matters. This is 9 and it's greater than 5. So removing it will add a 1 to this last significant figure. So it becomes 3. So that way this is the answer. This is the physical answer, not the mathematical answer. Next we go to volume. So the volume of course is side cube. So if you do the cube, this is what you get with many digits after the decimal point, but you want only the first one. Now the first insignificant digit is 1, which is less than 5. So removing all the insignificant digits won't really do anything to this 7. So it remains 7. So this is the physical volume, 373.7 cubic meter. So we have another such example. In this example, we again calculate the density of a material, a substance. Say 5.74 gram of that substance occupies this much space, 1.2 cubic centimeter. So we have to calculate the density keeping the significant figures in view. So you can see that here there are 3 significant figures in the mass, but in the volume there are only 2 significant figures. So by the rule for division, the final answer should have 2 significant figures. With that in mind, let's see the solution. Okay, so this is the solution, and just like the previous example, here you write the density should have 2 significant figures because of those rules. Now the density can be calculated by dividing the mass by volume, and the answer mathematically looks like this. You can understand that these 3's go on and on without any end. Okay, 4.83333 and like that it goes. But we only want 2 significant figures. That means we have to remove all these 3's. They are insignificant. But because this first insignificant digit or figure, same thing, 3, which is less than 5. So its removal does not really affect anything. It does not add 1 to the preceding digit. So the physical answer is 4.8 gram per cubic centimeter. So this is where this rounding of thing ends. In the next physics video, we are going to see how to determine the uncertainty that you are having in this type of final answers due to working with approximate quantities, how to calculate that uncertainty, what it means. So we are going to see that in the next video. And tomorrow, of course, we have our usual upload, and I think tomorrow we have again linear algebra, and we are solving problems there. So see you tomorrow with that. Until then, this is me, Lucifer, from a mathematical room. Have a nice day.